All right, here's another example of integration by substitution. So we first of all, looking at this thing, we could actually just expand this by multiplying it together 12 times and then do the integral with the power rule. That, of course, would be horrible. So substitution gives us an easier way in this case. And again, our guiding principle is that we're looking for a part of this integral whose derivative is another part of the integral. And x squared, the derivative of x squared has to do with x. It's not exactly x, but it has the right power, so it's close. So that's what we're going to do. We're going to let u equal x squared minus 3. That, if we make that substitution, that's going to allow us to replace this part of the integrand, which would be good news. Right? The derivative, du, will be 2x dx. And we have, in our original integral, an x dx. So we're going to want to replace that with things involving u. To do that, let me just solve here. Du over 2 equals x dx. In these substitution problems, we treat du and dx like they're numbers, even though they're not, even though they're just notations indicating what the variable of integration is. We treat them like they're numbers for these substitutions, and the substitutions work out. So we have an x dx, which we can use to replace an x dx. We have an x squared minus 3, which we can use to replace an x squared minus 3. And we end up with an integral of u to the 12th. That's x squared minus 3 to the 12th. X squared minus 3 is u, so we replace that with a u. And then x dx, we see, gets replaced with a du over 2. So we have 1/2 integral of u to the 12th du. And we've done the substitution. The substitution is complete when the integral that used to involve x's and dx's now involves only u's and du's. So now it only involves u's and du's. The substitution is complete. And the substitution works if we end up with an integral that's easier than what we originally had. And in this case, we did. We got an integral that we can do with the power rule, which is great news. So we have u to the 13 over 13 times 2 is 26 plus c. Finally, we want that back in terms of x, since our original problem was in terms of x. So we have x squared, was it minus 3 to the 13 over 26 plus c. That is our antiderivative. Now, you can always go back when you have an antiderivative. You can always just take the derivative of it and check and see if you got the right answer. You do that with the chain rule here, but there it is. That's the antiderivative.